NFPA 70E and OSHA, the Occupational Safety and Health Administration, have a significant relationship in ensuring electrical safety in the workplace. Firstly, OSHA recognizes NFPA 70E as an industry consensus standard. This means that employers can use NFPA 70E to comply with the General Duty Clause of the Occupational Safety and Health Act, also known as the OSH Act. Secondly, both NFPA 70E and OSHA promote a hierarchy of controls to prevent electrical accidents. This hierarchy prioritizes different methods of risk reduction, starting with the most effective and moving to less effective measures. The hierarchy of controls includes several levels. One is elimination, which involves removing electrical hazards altogether. An example is de-energizing equipment instead of working on it live. Another is substitution, which means using less hazardous materials or equipment. For example, replacing a 480 volts motor with a 120 volts motor, if feasible for the application. There are also engineering controls, which involve physically isolating or shielding workers from hazards. This could include installing machine guarding or using insulated tools. Additionally, administrative controls include establishing work practices and procedures to control hazards, such as implementing lockout-tagout procedures or requiring specific training. Finally, personal protective equipment, or PPE, is used as a last resort. This includes items like gloves, safety glasses, and arc-rated clothing. The hierarchy of controls emphasizes that PPE should only be relied upon when other controls are not feasible or do not provide sufficient protection. Thirdly, NFPA 70E provides a framework for conducting hazard assessments and developing risk management plans. OSHA requires employers to conduct hazard assessments and implement mitigation measures to prevent or control electrical hazards. The hazard assessment process involves identifying potential electrical hazards in the workplace, evaluating the risks associated with those hazards, and implementing appropriate controls to mitigate those risks. NFPA 70E offers guidance on how to perform these assessments and develop comprehensive risk management plans. Fourthly, NFPA 70E establishes specific training and qualification requirements for electrical workers. OSHA also requires employers to provide training on electrical hazards to workers who may be exposed to them. Training is crucial for ensuring that workers understand the hazards associated with electricity and how to work safely around it. NFPA 70E specifies the topics that should be covered in electrical safety training, as well as the qualifications that workers must possess to perform certain tasks. Fifthly, NFPA 70E outlines specific electrical work practices, such as lockout-tagout procedures, grounding, and testing. OSHA's electrical safety standards also include requirements for work practices to minimize electrical hazards. Following safe work practices is essential for preventing electrical accidents and injuries. NFPA 70E provides detailed guidance on how to perform various electrical tasks safely, while OSHA's standards establish the legal requirements that employers must meet. Beyond the General Duty Clause, NFPA 70E is related to several specific OSHA standards. These include 29 CFR 1910.132, which covers personal protective equipment or PPE. This standard requires employers to provide and ensure the use of appropriate PPE for employees exposed to electrical hazards. Another is 29 CFR 1910.147, which addresses the control of hazardous energy or lockout-tagout. This standard requires employers to establish procedures for de-energizing equipment and preventing the unexpected release of hazardous energy during maintenance and servicing. Another OSHA standard is 29 CFR 1910.331, which focuses on electrical safety-related work practices. This standard outlines safe work practices for employees who work on or near electrical equipment. And finally, 29 CFR 1910.333, which covers the selection and use of work practices. This standard provides guidance on selecting and using appropriate work practices to minimize electrical hazards. To summarize, the relationship between NFPA 70E and OSHA is one of collaboration and mutual reinforcement. NFPA 70E provides detailed guidance and best practices for electrical safety, while OSHA establishes the legal requirements that employees must meet. By following NFPA 70E and complying with OSHA's standards, employers can create a safer work environment for their employees and reduce the risk of electrical accidents. It is important to consult with a qualified electrical safety professional to ensure that an electrical safety program complies with both NFPA 70E and OSHA regulations. These regulations and standards are constantly evolving, so it's crucial to stay up to date and ensure that electrical safety practices are in line with the latest requirements. The National Electrical Code, or NEC, also plays a role in electrical safety. While the NEC is primarily concerned with the safe installation of electrical systems, it also has implications for worker safety. For example, the NEC includes requirements for grounding and bonding, which are essential for preventing electrical shock hazards. The NEC also addresses issues such as arc flash protection and the use of personal protective equipment, or PPE. When developing an electrical safety program, it's important to consider both the NEC and NFPA 70E, as well as any applicable OSHA regulations. In addition to training, hazard assessments, and safe work practices, another important aspect of electrical safety is equipment maintenance. Regular inspection and maintenance of electrical equipment can help to identify and correct potential hazards before they lead to accidents. This includes checking for damaged insulation, loose connections, and other signs of wear and tear. It's also important to ensure that equipment is properly grounded and that all safety devices are functioning correctly. When performing maintenance on electrical equipment, it's essential to follow lockout-tagout procedures to prevent the unexpected energization of the equipment. This involves disconnecting the equipment from its power source and placing a lock and tag on the disconnect switch to indicate that the equipment is being worked on. Only authorized personnel should be allowed to remove the lock and tag after the maintenance is complete. Another important consideration is the use of appropriate tools and equipment for electrical work. This includes using insulated tools, such as screwdrivers, pliers, and wrenches, to protect against electrical shock. It's also important to use voltage testers and other measuring devices to verify that equipment is energized before working on it. When working on or near energized electrical equipment, it's essential to maintain a safe working distance. This distance is determined by the voltage of the equipment and the type of work being performed. NFPA 70E provides tables that specify the minimum approach distances for different voltage levels. It's also important to be aware of the potential for arc flash, which is a dangerous electrical explosion that can occur when there is a fault in an electrical system. Arc flash can cause severe burns, blindness, and even death. To protect against arc flash hazards, employers should conduct arc flash hazard analyses and provide appropriate personal protective equipment or PPE such as arc-rated clothing and face shields. In addition to the technical aspects of electrical safety, it's also important to foster a culture of safety in the workplace. This means promoting open communication, encouraging employees to report hazards, and providing ongoing training and education. It's also important to recognize and reward employees who demonstrate a commitment to safety. By creating a strong safety culture, employers can help to prevent electrical accidents and injuries and create a safer work environment for everyone. Electrical safety is a shared responsibility. Employers, employees, and other stakeholders all have a role to play in ensuring that electrical work is performed safely. By working together, we can prevent electrical accidents and create a safer work environment for everyone. When selecting personal protective equipment or PPE for electrical work, it's important to choose equipment that is appropriate for the specific hazards involved. This includes considering the voltage level, the potential for arc flash, and other factors. It's also important to ensure that the equipment is properly rated and meets applicable standards such as ANSI or ASTM. For example, gloves used for electrical work should be made of insulating material and should be rated for the voltage level to which the worker may be exposed. Similarly, arc-rated clothing should be made of flame-resistant material and should be rated for the level of arc flash protection required. In addition to selecting the right PPE, It's also important to ensure that it is properly maintained and used. Gloves should be inspected regularly for holes or damage, and ARC-rated clothing should be cleaned and stored according to the manufacturer's instructions. Workers should also be trained on how to properly use and care for their PPE. When working with electrical equipment, it's important to be aware of the potential for static electricity. Static electricity can build up on clothing, tools, and other objects, and can discharge when the object comes into contact with a grounded surface. This discharge can cause a spark, which can ignite flammable materials or damage sensitive electronic components. To prevent static electricity hazards, it's important to wear static dissipative clothing and use static dissipative tools and equipment. It's also important to ground any equipment that may be susceptible to static electricity buildup. Another important consideration is the use of ground fault circuit interrupters, also known as GFCIs. GFCIs are devices that are designed to protect against electrical shock by detecting ground faults and quickly interrupting the flow of electricity. GFCIs are typically required in wet or damp locations, such as bathrooms, kitchens, and outdoor areas. They are also recommended for use with portable tools and equipment. When using extension cords, it's important to choose cords that are the appropriate size and length for the application. Overloaded or undersized extension cords can overheat and cause a fire. It's also important to inspect extension cords regularly for damage and to replace any cords that are frayed or damaged. When working outdoors, it's important to be aware of the potential for lightning strikes. Lightning can travel through electrical systems and cause damage to equipment and injury to personnel. To protect against lightning strikes, it's important to stay indoors during thunderstorms and to avoid contact with electrical equipment. It's also important to ensure that buildings and electrical systems are properly grounded to provide a path for lightning to travel to the ground. In addition to the topics covered above, there are many other aspects of electrical safety that are important to consider. These include the safe use of ladders and scaffolding, the proper handling of hazardous materials, and the importance of emergency preparedness. By staying informed and following safe work practices, we can help to prevent electrical accidents and create a safer work environment for everyone. Electrical safety is a continuous process of learning, adapting, and improving. By staying up to date on the latest regulations, standards, and best practices, we can ensure that we are doing everything possible to protect ourselves and others from electrical hazards. In closing, electrical safety relies heavily on understanding the relationship between NFPA 70E and OSHA regulations. These organizations provide guidance, standards, and legal requirements necessary to mitigate electrical hazards in the workplace. Adherence to these guidelines ensures a safer working environment for all personnel involved. Remember to always consult qualified professionals for program compliance and stay updated with evolving safety practices.